So today we're going to continue with solving systems of equations. And so what we're going to do now is we're actually going to do the algebraic ways. So you did the graphing ways, which you found were probably the most tedious ways, and they probably took you a little bit of time, and you probably got a little frustrated, and that's generally what happens with the graphing. So now what we're going to do is we're going to look at how you can use this algebraically. And so there are two ways to do this algebraically. There's substitution and there's elimination. Okay, now of those, you're going to have to use both. Okay, but then there will be some that you get to choose which way you want to solve. So we're going to first of all start with substitution. And you might remember this from Algebra 1 because we did cover this a little bit in Algebra 1. So remember, for substitution, we need to solve one equation for one of the variables. Okay, so if I look, is there just a variable that's by itself? Which one? Y in what equation? The second. So I'm going to solve this for y. So that means y would equal 7 minus 2x. Correct? I mean, that's what it equals. In fact, I think what I'm going to do now is I'm going to write it down here. So now with substitution, when we think about substituting something, that means replacing it. So I'm going to go to the top equation. Since I've already done the second equation, I'm going to leave it alone. Go to the top equation, and in place of y, I'm now going to replace y with 7 minus 2x. So I've got my 5x, that's still fine and good. I've got my minus 3, but in place of the y right here, I'm going to put 7 minus 2x. So all I did is replace y with the 7 minus 2x. So now to solve this, I'm going to distribute, and I'm going to distribute that negative 3. So I have my 5x. What is negative 3 times 7?
Negative 21.
Negative 21. What is the negative 3 times negative 2x?
6.
So now let's go ahead and add like terms together. What do I get on the left side? 11x minus 21 equals 23. So now I need to solve that for x. So what do you need to do? Add 21 to both sides. So I get 11x to equal 44. So this one actually works nice because it does come out to be an even number. What does x equal? 4. So now once you get what x equals, you're going to go back to this equation right here, and you're going to substitute 4 back in. So in this case, I get y to equal 7 minus 2 times 4. What is 2 times 4? 8. So what is 7 minus 8? Negative 1. So my solution then is going to be 4, negative 1. The reason why you answer it as an ordered pair is because yesterday when you graphed, you found those intersection points. And that's actually what happens here. Okay, if I were to graph these two lines, they would intersect at the point 4, negative 1. Yeah?
So how would you reverse the initial equation with this second equation?
Yeah, this one?
Yeah, we have to.
I started with that one and then I substituted in 7 minus 2x for y. All right, let's look at another one. So we have negative 6x minus y equals 27. And then 3x plus 8y equals 9. So our goal is to solve this for a single variable. Okay, so you can solve it for y in the top equation. The thing is, if I add 6x to both sides, I'm going to get negative y equals 27 plus 6x. Okay, do you see what I did? I just added the 6x there. But I don't want it for negative y, so I need to solve it for positive y. So I'm going to switch the sign. So really, what would y equal? Negative 27 minus 6x. So now I'm done with that first equation. okay, until the very end. I'm going to go to the second equation. And in place of y, what am I going to put? Negative 27 minus 6x. And that's going to equal 9. So you get 3x plus, what's 8 times negative 27? Negative 216. Okay, what's 8 times negative 6? Negative 48x. Let's add like terms together. Negative 45x minus 216 equals 9. What do you do now?
Add 216.
Add 216, so I get negative 45x equals 225. Very good. So then what does x equal? Negative 5, because that was a negative 45 that we divided by. Once you get that negative 5, you're going to take that negative 5 and you're going to plug it in up here. So I've got negative 27 minus 6 times negative 5. Now notice we have quite a few negatives, so we need to make sure that we don't mess up here. So I get negative 27 minus, what is 6 times negative 5? Negative 30. What do you know about the two negatives? They make a positive. Oops, can't see it there. So what does y equal? 3. So your solution is negative 5, positive 3.
He's really cute.
Okay. So any questions on the substitution? Okay, you can handle the substitution. Now the other one, if you remember, was elimination.
I hate these.
Okay, now I actually like elimination. That's my favorite. Okay, so you're probably going to have the one that you like a little bit better than the other, and that's fine. So with elimination, remember our goal is to eliminate one variable. And in this case, I can eliminate one variable. What variable can I eliminate?
3y.
I can eliminate the 3y. So how can I eliminate that? I can eliminate that by adding the two equations together. So if I add those two equations together, I get 4x plus 2x, which is 6x. The 3y and the negative 3y cancel. They give me 0. Equals, on the right side I have negative 22 and positive 16. Negative 6. So then now I'm going to divide, and I get x to equal negative 1. Now this is the downfall with elimination. Elimination generally at the beginning is a little bit faster, but then now when I substitute it back in, it's not as nice as it was with substitution. Because I have to plug x back in. Now I can plug it into either the top equation or bottom equation. It doesn't matter which one. Okay? I could plug it into the bottom equation. The only reason why I chose the bottom equation is because it's got all the positives. The top equation has some negatives. So then now I get negative 2 plus 3y equals 16. And so now some of you are probably seeing why I said this one now takes a little bit of time. So what does 3y equal? 18. So then y equals 6. So your ordered pair is negative 1, positive 6. Okay, now that one worked out nice and neat because they eliminated right away from the beginning. They won't always be that easy though. Okay, this problem, let's look at this. What do you notice? They're both negative. And see, in order for it to work, we really need to have one negative, one positive. So all I'm going to do is I'm going to take one equation, and I'm just going to switch all the signs. This has the effect of multiplying by negative 1. That's what you're doing. So let's add them together now. What do you get? 2x equals 4. Okay. So what do you get x to equal? 2. So now we're going to plug it in. I'm going to plug it in that top equation because I haven't manipulated that at all. And it's the same. That way if I made a mistake in the bottom equation, it won't throw off at least this part. So what do I get? 12 minus 5y equals negative 8. So I get, yep, negative 5y to equal what? Negative 20. So what does y equal? 4. Very good. So you should get your ordered pair to be 2, 4. Now in this problem, if you were wanting to do substitution, it's going to be a mess. Because what you would need to do is have to solve for a variable, and you're going to get some fractions in there.
If they don't have the same number in front of the variable.
That's what we're going to get to now. 50. Okay, so now, once again, you could try substitution here, but you're going to have to solve for either x or y. You're going to get fractions. It is just not the best choice. So we're going to choose to use elimination here, but if you notice, I don't have opposite signs, and I don't have the same number. I have a 2 and a 6, a 3 and a 9, so I need to think to myself, okay, could I multiply one equation by a number and get it so that it was the same number as the other equation? Okay, what could I do? Multiply the top by 3, and you know what I'm going to do? I'm going to actually multiply this by a negative 3. The reason I'm going to use a negative 3 is because then the signs will be opposite, and then you can just add it, and it'll work really slick. So my top equation now becomes negative 6x. Okay, bottom equation is going to stay 6x plus 9y equals 15. So let's go ahead and add them together. Oh, what do you get on the left side? 0. Equals. Is that a true statement? Does 0 equal 0?
Yep.
So since this is a true statement, this is actually all real numbers. Any number you plug in there will work. Now, if this had been a false statement, if it had been like something like this, 0 equals 2, okay, that's a false statement. As a result, this one would have been a no solution. Okay, so if it's a true statement, like if it would be 5 equals 5, or 0 equals 0, or like negative 1 equals negative 1, that would be an all reals. If it's a false statement, it would be a no solution. Okay, let's look at this one. Ooh.
You
Okay.
multiply both of them?
Yeah, that's what we're probably going to have to do. We're going to have to multiply both. So I need to look at the numbers 8 and 5 and 3 and 2. Which one's the easier of the two? I'd probably mess with the 3 and the 2 because 1, the signs are already opposite. 3 and 2 both go into what? 6. So what am I going to multiply the top equation by? Bottom equation by? So the top equation becomes, okay, minus 6y, yep, equals 22. Bottom equation becomes negative 9. What do you get on the left? 31x equals negative 31. So what does x equal? Negative 1. Now, we've got 4 different equations we can plug it into. We can plug it into one of the black equations, or we can plug it into one of the purple equations. I would probably stick with the black equation. In fact, I'm going to stick with the bottom one, the 5x plus 2y. That's the one I'm going to use. Okay?
Even though you multiplied it, you don't.
Yeah, I'm just going to use the original equation from the problem. So I've got 5 times negative 1 plus 2y equals negative 3. So negative 5 plus 2y equals negative 3. What do you get 2y to equal? 2. So then y equals 1, so your solution is negative 1, 1. Pretty straightforward? Alrighty. Let's look at this one. Multiply the top one by negative 3. Okay? So on the top I get, yep, okay, negative 156, yep. Bottom equation stays 15x plus 9y equals 54. What do you get on the left? Yeah, 0 equals, what do you get on the right? Negative 1, 02. True statement? No, that's not true. So since it's not true, your answer is no solution. Remember, if that would have been a true statement, like 0 equals 0, you would have done all reals. But since it's not a true statement, you have no solution. Okay, so this is what's going to happen. Okay, your assignment is actually still in this section that we did yesterday. So I need you to add 44 through 58, the evens, to the one I gave you yesterday. 44 through 58, the evens.